Three of the most fundamental things to know about electricity are the voltage, current, and resistance of circuits and wires. But most of the time, when people go about explaining that to someone for the first time, they just give a bunch of mathematical equations, like in this video, or they just draw a bunch of circuit drawings without really giving any intuition for why it's occurring. They might draw maybe or simulate a lot of electrons moving inside of a wire, but that doesn't really give very good intuition for like why it's occurring or you know really underlying intuition that really makes you believe that electricity works. Most of these videos you just kind of walk away being like, oh, okay, well, I guess that is how electricity works. But I really want you to walk away from this video really understanding, oh, well, it makes sense that electricity works that way. One of my issues is that what people try and do is they use this analogy of water for electricity. You might describe the current of electric flow as the amount of current that's flowing through a pipe, which is actually not too far off from what's happening. But then the issue comes up when you talk about voltage. And most people relate the voltage of an electrical circuit to the pressure inside of, a water pipe, which doesn't really make a lot of sense. And for anyone that's really thinking about it, you'll normally walk away feeling really uncomfortable with this idea. Like, it doesn't really make sense for why that should be, and it's not a perfect analogy. And so, rather than making a bunch of analogies for how electricity works, I'd rather just go back to the fundamentals of why it works. And once you understand everything that builds up and explains why it works, I feel like you'll have a really good intuition about electricity. And you'll sit there and think, oh, okay, well, it really should make sense that electricity flows, that there's amount of voltage and resistance in wires, and why current and voltage and resistance are related. And so I'm going to go about explaining electricity through chemistry. But before we do that, we do need to sort of review a little bit. So from basic chemistry, you'll remember that most atoms have a nucleus in the center, and they have electrons that will orbit around them. And each one of these different orbits will have a certain amount of energy related to it. So we call each one of these different energy levels. So electrons here will exist at a certain amount of energy, and electrons here will all have their own energy level that can be represented in a chart like this. So right down here, we have the nucleus of the atom, and above it, you'll have these different orbitals. So here you have your 1s orbital, and then here you'll have your 2s and 2p orbitals, and each one of these relate to discrete amounts of energy. So if an electron lies in any of these electron orbitals, they'll have a discrete amount of energy associated with them. Now, also remembering from chemistry, we know that there are different types of bonds between atoms. So you might have a single atom, but what happens when you have two atoms that may interact with each other? You'll have sometimes what's called a covalent bond, where electrons are shared between these two atoms. Another time you might have what's called an ionic bond, where two atoms each have their own electron, but one of the atoms may steal the other's electron, and so one becomes negatively charged, the other becomes positively charged, and they're attracted to each other. This would be called an ionic bond. And so, okay, we remember covalent bonds that may share electrons, and we have ionic bonds that may steal electrons, but what type of bond is a metallic bond? Well, metallic bonds actually fall into neither one of these categories. They actually are a special type of bond in which all of the electrons become delocalized. So each one of these electrons exists as a wave function that we remember from quantum mechanics. And when all of these electrons interact with each other, they blend and mesh into delocalized electrons. Kind of strange, but what you can think of that as is that in comparison to the covalent bonds, where these electrons exist between these two atoms, and ionic bonds, where one of the atoms has most of the electrons, what happens with metallic structures is that it becomes what's called a sea of electrons. So actually, all of these electrons can flow freely throughout this structure. No particular electron is bound to an atom. This electron can actually flow anywhere in the structure, and it's not bound to any specific atom. So this is called a sea of electrons. These electrons can exist anywhere up, down, left, and right, and can flow freely in any of those directions. Now, there's also something that happens to the energy levels. So unlike regular singular atoms that have discrete energy levels, what happens when you have multiple atoms interacting with each other, especially for metallic structures, what ends up happening is these energy levels end up blending together. In fact, all of these energy levels blend together into what's called an energy band. And so now all of these electrons can exist at a continuous range of energy states. So rather than energy levels, it's now a continuous sweep of energy. And so now electrons have freedom in space and in energy. And so that will be important for really understanding why does electricity flow in a wire, and why is there things like voltage and current. And so this video is sort of just a background on the review and chemistry that you'll need to know to understand what's coming next.